15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And hello once again. Thank you for joining us on this edition of Space Nuts, the podcast, episode 177. My name is Andrew Dunkley. I'm your host, and with me, as always, is Astronomer-at-Large, Professor Fred Watson. Hello, Fred.
Hey, the host with the most.
Most what? Most space between my ears, I think, would probably be appropriate.
That's it.
Yes. Today, Fred, we've got a lot to discuss. We're going to talk about the mole stuck in a hole on Mars. We're going to look at a new image that confirms a dwarf planet, and this one might be the smallest one yet. And a few questions today, one about white holes, one about looking through a telescope. It's actually an interesting question, and we'll double up with another question about the mass outside the universe. What could that be doing? And an interesting fellow who spent some time down at Mawson Station in Antarctica asking about gravitational waves, but he also sent us some amazing photos from down there. Oh, my gosh. Hopefully he's put them on the Space Nuts Facebook podcast group. Yeah, that's it. I could never get that right. And shared them with everyone because they are stunning. They are stunning pictures. But let's get back to the mole in the hole, Fred. This is a little bit of an issue with the InSight Mars lander. One thing they've noticed is it's not doing what it's supposed to do entirely.
That's right. Part of it is not doing entirely what it's supposed to do. So recall that InSight is a spacecraft sitting, if I remember rightly, somewhere near the equator of Mars. It is designed to probe Mars's interior. So it's not really looking at the surface particularly. It's not looking for signs of past life or anything like that. That will be the province of Mars 2020, which will be launched next year. Not surprising given the name. InSight, though, is a spacecraft that is equipped with, so basically it just sits on the surface. It doesn't have wheels. It's a lander based actually on Phoenix, the lander that investigated the Martian Arctic back in 2008, if I remember rightly. So its InSight is a lander which is equipped with two principal instruments. One is a very accurate and very sensitive seismometer. So it's listening for Mars quakes, and that side of things have been very successful. And you and I have actually spoken about that not in the not too distant past. The fact that something like, I think it's well over 100 quakes have been registered, of which I think only a percentage are genuine Mars quakes. Some of them are caused by the wind and things like that. Here we are, 150 events detected to date, 23 of which have been confirmed as Mars quakes. Wow. And the Mars quakes are of great interest because you can analyze those and work out what it's come from. But the other side of InSight's armory of instruments, or the other facet of that, is a device which rejoices in the name of HP3. Now, HP3 is an acronym. It's not easy to pronounce, but it's HP3, and it stands for the Heat Flow and Physical Properties Package. And that's where the 3 comes from. Physical Properties Package.
I thought it was hard to put in a hole.
Quite so. Oh, you should be on the radio, Andrew. With a bit like that. You should be somewhere else anyway.
Yes, probably. My wife says that all the time. Can you be somewhere else?
Yes. Yes. Anyway, I won't make any suggestions as to where you might be. But the Heat Flow and Physical Properties Package was actually, it's from the German Aerospace Center. So it's because InSight is a multinational facet. So HP3 is the one that is in the news. And that is because, as its name implies, heat flow and physical properties package. The main one of the main functions of this device, HP3, is to measure the heat coming from Mars's interior. And in order to do that, you don't want to just dump a thermometer on the surface, because the surface is affected by radiation from the sun and by, essentially local environmental effects. So the idea with InSight was that the heat probe itself, the HP3, was equipped with, or is equipped with, a thing that is called the mole. And the mole is essentially a device that digs its way into the soil and goes down, actually, up to 5 meters was the original plan, to get this heat probe well under the surface of Mars. So what you're feeling is the effect of, principally, you're measuring the effect of heat coming up from the interior. You can sort of compensate for what comes down from the surface.
Because you don't have to go down far into the Earth to feel the heat.
No, that's right.
I've been down one of the mines out west here. I went down somewhere like 370 metres, and it was like 50 degrees down there.
Yes.
It was that's stinking hot.
Third of a kilometre, that's right. Until you're detecting kind of tens of degrees of increased heat. On Mars, this sensitive thermometer, as it is, basically can measure very much more minute differences in temperature. So yes, it's able to detect the heat coming from Mars's interior, or it would be if it could be put in the right place, because this mole device, which is supposed to take it down to 5 meters, it's a kind of self-hammering thing. It's probably got a mass inside it that is banged against the end and then retracts within the mole. It's a cylindrical device, kind of
pile driver type of thing.
It's like a baby pile driver, that's right. But it's after they started digging it down into the surface several months ago now, actually, it got stuck. It went down about 30 centimeters, which is not 5 meters, and then stopped. And so the question that arose was what's stopping it? And one possibility was a rock. But another one, which seems to be the more likely, basically the cause of this problem, more likely cause, is that the mole itself has lost friction with the dirt around it. So it seems to need, as it bangs its way down, it seems to need a certain amount of friction between the outside of the mole and the surrounding dirt itself. And that has not happened, apparently. The thinking is that the interaction with the Martian soil has been unexpectedly poor.
I've seen the soil described scientifically as weird.
Yes, weird is the technical term for the soil of Mars. It's got weird properties. I think it's the fact that it is a very fine dust. We know that you get these dust storms on Mars. It's very, very dry. There's virtually no moisture in it at all. And moisture, of course, helps with packing soil around things. So has been the thinking. So what they did was they lent on it with the sort of digger arm that it's not really a digger arm. It's got a technical name which is eluding me at the moment.
Spade.
What is it? The device that it's basically it's the robotic arm. That's what it's called. It's a robotic arm.
It looks like a spade.
Yeah. It does, but it's not meant for digging. That's the thing. The one on Phoenix it's the same device. Phoenix had a kind of backhoe arm that was used to scrape away the surface soil, and that's how we know that there's a permafrost of water ice in the Martian Arctic. I don't believe the robotic arm, to give it its technical term, on InSight has a digger on the end of it. But what they did was basically they put the robotic arm on to kind of give the mole a push downwards, then took it away, and what happened was the mole popped out. It didn't stay down. It's kind of popped out of its hole, and that's not what the desired effect was. They wanted it to go down, and
we're starting to hear a lens cap scenario here.
Yes, it's a bit like that. It's not popped all the way out. It's come out about halfway out of its. Can
they try a different spot?
I'm not sure. I would guess they can, because that's probably what the robotic arm is for. But you would think they would have already tried that.
I'm looking at some photos that they've taken of the operation. I think I've figured out the issue. I think I might write them an email.
You should do.
Somebody's drawn a circle with a cross in it, which I envisage is a target, and they missed. That's what I reckon's happened here.
But yes, I don't know whether a circle with a cross on it on one bit of Martian soil is any different from a circle with a cross on it on another bit of Martian soil.
I don't know. I built a house on a piece of land that looked perfectly normal until we started finding giant chunks of sandstone.
Oh, well, there you go. And it could, it's still possible it could be something like that they've just been unlucky and they've come up against a big lump of rock. Under, foot underneath the soil.
I guarantee you that rock is not under the circle with the cross in it. I don't know how they did that, but somebody snuck on the surface and drawn that there and said, we should put it in here. And so the scientists have gone, no, not at all.
I actually think the circle with a cross in it, I think is probably the end of the robotic arm.
Gosh, there you go again. Not letting the truth get in the way of a good story once again.
Yeah.
Gosh.
Well,
anyway, they're still trying to fix it, is what I gather.
Yeah, and I should send NASA an email, Andrew. They'll probably be very happy about that.
Yeah, I think they listen to us, so the message has been delivered. I'm sure they listen to us.
I hope they don't. We should lift our game if NASA are listening. Tell you.
Comic relief, I think, would. That's what they get out of us.
Yeah,
comic relief. So we will wait with bated breath and hope that they can solve this problem, because it would be really fascinating and beneficial to find out what's going on down there.
Yeah, it would. Absolutely.
All right. Let's keep an eye on that one. You're listening to Space Nuts. Andrew Dunkley here with the great Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
And thank you again to our patrons who are signing up in, ones at patreon.com to support our podcast. If you would like to do that, become a member of the Space Nuts Patreon group. You can do that at patreon.com/space nuts. You can sign up for an amount of your choosing. And listen to, you get special advanced screenings of Space Nuts too, by the way, but also other benefits on the agenda in the not too distant future. I mean, we're probably talking millennia here, but anyway, if you'd like to join us via Patreon, patreon.com/space nuts is the place to do that. And we thank the patrons who have already done so at whatever level. We really appreciate your support. It is fantastic. I bought a Chupa Chup with my share. Now, Fred, we are going to talk about a dwarf planet. We've known about it for a while, but now they've managed to secure an image of this bonker-sized spheroid and confirm that it is probably the smallest dwarf planet found so far. I should qualify that by explaining what a bonker is. When I was growing up, you played marbles and the big one was called a bonker. I'm pretty sure they call it something else in other countries, but we called it a bonker. I don't know where that came from. And these days that kind of doesn't fit in with social acceptance. But anyway.
It doesn't. Where I grew up, Andrew, we call the big ones the bollies.
The bollies.
It's a bolly, yeah.
A bolly, yeah.
So a bolly is slightly more politically correct than a bonker, I think. It's not much to choose between them, really.
These days, yeah. I never played for keeps when I played because I liked my marbles. I didn't want anyone taking them from me.
Absolutely.
I tended to avoid those games. But yeah, we're looking at some work that's been done through the Very Large Telescope, and they have discovered, well, they haven't discovered this dwarf planet, but they have probably confirmed that it is indeed a dwarf planet, because I suppose they've been trying to figure that out for a little while.
That's right. I think this is a really nice story, and what it highlights is the capabilities of the Very Large Telescope, which you'll remember is actually not one but four telescopes, each with an 8.2 meter diameter mirror, sitting on a mountain in Chile called Cerro Paranal, operated by the European Southern Observatory. And they are, if not certainly among the finest equipped telescopes in the world, certainly in the Southern Hemisphere. So the VLT, one of those four telescopes, is equipped with an instrument called SPHERE. And SPHERE is a relatively new instrument specifically designed for looking in detail at things a long way away. In other words, doing fine resolution imaging. So SPHERE is actually an acronym, as you might expect, and the acronym kind of tells you what it's for. It stands for Spectropolarimetric High Contrast Exoplanet Research.
They're just making that up.
Of course they are. That's what you do with acronyms. You think of a nice word and then fit your other words to it. I used to do it myself.
Oh, dear.
I used to build instruments. What does spectropolarimetric mean? It means you're looking at the polarization of the light coming from the target object. And polarization is something we're familiar with if you use polarizing sunglasses. You eliminate some of the vibrations that the light waves themselves participate in. So you're eliminating half of that. And it actually is a very powerful tool in astronomy. Polarization can tell you about dust in space. It can tell you about the way light has been affected by its passage through other media. It's a generally useful thing. In this case, it's combined with spectroscopy, which is the breaking up of the light into its rainbow colors. So spectropolarimetric is a very capable analytical tool. But the main thing about SPHERE is that it's used in conjunction with what are called adaptive optics. And adaptive optics use flexible mirror technology coupled with some very sensitive devices in order to eliminate the distorting effect of the Earth's atmosphere. As light comes through the Earth's atmosphere, it's affected by pockets of hotter and warmer and colder air, and that basically blurs the image. But with clever technology, you can actually sense that distortion. And a little bit like you sense the ambient noise in a pair of noise-cancelling headphones. You sense the ambient noise and then put an inverse signal in that cancels it out. It's very much the same sort of thing, but you're doing it with light. And adaptive optics technology basically removes, to a large extent, not completely, but to a large extent, it removes the distorting effects of the Earth's atmosphere. So you can get very sharp imaging. In fact, you can make it comparable with the Hubble Space Telescope, which is above the atmosphere altogether. I have to say the ground-based telescopes like the VLT are very much cheaper to run than a space telescope. Okay, so that's the backstory. But
especially if you can put it on the top of a mountain that exceeds, someone's ability to breathe properly.
Yeah, it's not actually. Cerro Paranal is not quite that high. It's,
okay.
if I remember rightly, it's about 3,000 meters, which is a lot more amenable than the 4,200 meters, which is at Mauna Kea, where another suite of telescopes are in Hawaii. You and I have both been there. I bet you haven't been to Paranal, though. I have.
No, have not.
Yes, sorry, that's just a bit of bragging there. ESO astronomers, and in particular, I think it's a group, if I remember rightly, it is from the Laboratoire d'Astrophysics de Marseille, which is in France, if you can decipher my horrible French accent. It's researchers based there who have used this instrument to look at one of the asteroids in the asteroid belt, the main belt of asteroids between the orbits of Mars and Jupiter. And they found that one of them, the fourth biggest of the asteroids, whose name is Hygeia, I suppose it should be, depending on how you pronounce it. It looks like Hygeia.
That's what I thought it said.
Hygeia is probably how it's pronounced. Depends on whether you lengthen your Y's or not in ancient Greek. Anyway, the bottom line is this thing is round. It's more or less a spherical shape, not a perfect sphere, but very close to it. And for an object like Hygeia, for it to be spherical means that it qualifies as being a dwarf planet, because one of the requirements for an object to be a dwarf planet is that it is
a sphere.
Well, it's being pulled into a spherical shape by its own gravity.
Right.
The technical term is differentiated. It means that the inside stuff has been graduated, if I can put it that way, by gravity, and what you end up with is a sphere. And it is, when you look at the images that we've seen from ESO, the European Southern Observatory, there's this very distinctly round-looking object. It will be the International Astronomical Union, that august body, sometimes known as the Uber nerds, because they sit above all the rest of us nerds. They will look at the evidence for Hygeia being a dwarf planet, and they'll take a vote on it. And once they've done that, we might have an announcement that says, here is the smallest of all the dwarf planets in the solar system, because it's only 450 kilometres in diameter. I beg your pardon, about 430 kilometres. It's
that's not big at all, is it really?
As we speak. It's not big at all, no, that's right. And it's very near the limit below which things don't have enough gravity to make themselves spherical.
So it's a threshold object.
Oh, that's a very nice way of putting it. It is. It's there are moons of some of the outer planets, particularly I'm thinking of moons of Saturn, which we know very well thanks to the Cassini mission. Some of those moons are actually spherical, and they're not that much bigger than Hygeia is. But I think the asteroid counts, certainly because it's in orbit around the sun rather than being in orbit around another object. It is a planet, but a dwarf planet because of its small size. Actually,
I suppose finding all these objects and confirming them as dwarf planets does, in fact, justify the decision to put Pluto in that category. When we thought for so long that it was the only one, now we know that that's not the case.
Exactly, that's right. I agree with what you've said wholeheartedly. Not everybody does. Many people think Pluto is a special case, but if you make it a special case, then where do you draw the line?
Yes, precisely. The other weird thing about Hygeia is that it is seemingly unblemished.
Yes, that's right. Everybody expected it would be, would have big craters on it, because there's a thinking that it was once probably involved in a collision with other objects, and that's because we think there's debris from that collision still in the asteroid belt. But no, it's got a few vague-looking markings on it, but it's not pockmarked by huge craters, which some of the moons of, for example, one of the moons of Saturn has. It looks like the Death Star because it's got this enormous crater on one side.
Yeah,
and likewise Phobos, which is the bigger moon of Mars, that's got a big crater in it too.
I think one of those strange markings on Hygeia is a circle with a cross in it, Fred.
Gosh, you're right. You're absolutely right. Well, I can see a face in it too, so work that one out.
All right, so almost certainly a dwarf planet, but yet to be ratified by the Astronomical Union. So we'll wait until that happens. They'll send a memo, I'm sure.
They will, probably to you and I.
Yes, personally signed.
Fine.
You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
And before we get on to some questions, Fred, I have got to send out a special thank you to Matt Sayers. Matt is a Facebook influencer. Actually, I must say that he's a YouTube influencer, but he's also part of the Space Nuts podcast group, and he's been listening to us for a little while. He's got his own YouTube channel, and he did us a wonderful service the other day by giving us a huge plug on his Facebook channel, encouraging people to listen. So if you are listening to us for the first time, courtesy of Matt, thank you for that, and thank you to Matt for giving us such a great endorsement. Really appreciate it. It's lovely, and it saw our YouTube channel numbers jump significantly. So we're well on our way to hitting the 1,000. So if you would like to follow us on Facebook, subscribe to our channel, you can do that at youtube.com/c/spacenuts and subscribe there, and you can listen to all our back editions of Space Nuts right up to the latest version. You can even just hit the play all button and listen to them to your heart's content. I'm sure that'll be something your wife or husband will be thrilled with. Even make the kids do it. They might even learn something. Not from me, but they might. Now, Fred, let's tackle some questions. We've got a few to get through today, and this one comes from Josh, who is in Margaret River in Western Australia. What a beautiful part of the world. That's wine-growing territory, is it not, Margaret River?
Oh, it is.
Yeah. He says, excuse me if this has been answered in an episode I'm yet to get to. I think it has, Josh, but we want to revisit it because of your question. If black holes were to be a portal to a multi-universe or even another galaxy, could a white hole be on the other side of that, given that matter can only escape it? Could matter falling into a black hole then being emitted out of the other side from a white hole, possibly causing other big bangs? Or is this notion total science fiction? Hope you get to cover this. If it has already been covered, blah, blah, sorry. It's okay, Josh. We're going to tackle this one. Well, Fred is. I'm just going to sit here and giggle.
So let's go to the last question first. Is this notion total science fiction? And the answer is it's not, in the sense that when you look at the equations of general relativity, which are what form the basis of our understanding of black holes, you can reverse some of the signs, and what you get is a white hole. So material's not being sucked into it, it's being shot out. However, that might be the case, but we've never seen anything in observational astronomy that could qualify for a white hole, and we've certainly seen plenty of evidence that black holes exist. So the idea of white holes, black holes, a black hole white hole combination being a portal to another universe or to a multiple universe, that's a very common one, and it's one that is beloved of science fiction writers. It's usually called a wormhole. And whilst the mathematics let you allow for that, and there's nothing in the mathematics that forbids it, we've never observed it. And that probably means that they don't exist. So there must be something in the physics of the universe that actually stops it happening. And that might point to inadequacies in our understanding of gravity and our understanding of relativity, which is a good thing, because as soon as we find a hole in that, that means, well, to mix the metaphor,
all bets are off.
We can jump down it. Yeah, it means that there might be new physics. That's the bottom line.
Okay. There you go, Josh. No but yes, or yes but no, as the case may be. It's just all black and white, really.
Dear gosh, why do I have to put up with this?
Because we pay you the big bucks, Fred, that's why.
Oh, yeah, that's right.
That's it, isn't it? Next question. We have received this one from Jared Van Rooyen. I hope I pronounced your name correctly, and we're not sure where you're from. So we're going to say you're from Earth. He says, hello, Mr. Dunkley and Dr. Watson. I've always wanted to be able to say this. Jared, that's my father's name. Anyway, I have been listening to you guys for a few months now, And now he's going to stop. And I love it. I'm a college student studying astronomy, and I have some thoughts to maybe talk about. Firstly, I'd love to hear from you about what should be expected when looking through a standard telescope, and what your recommendation would be for new enthusiasts. Second, I'd like to ask a question I had thought of recently. What if outside of the universe we know there are huge amounts of mass surrounding us, and the gravity of this mass is what is increasing the speed of our universe's expansion? I don't know if that stands scientifically speaking, but I am curious. Thanks, Jared. Well, okay, where do you want to start? Telescopes?
Well, let's do the telescopes.
Mass of the universe.
Sorry, go on. I missed that.
Just which way do you want to start? Telescope or mass of the universe? I'd go with the second one. It's the easy one.
But the first leads to the second. So.
Okay, we'll go that way. Seeing you've written a book about telescopes, only fair that you should answer this one. I'll sit back.
I do like telescopes. There's no doubt about it. I've been fascinated by telescopes ever since I was a young lad, 100 years ago. But the thing that that really characterises the era in which we live is that telescopes are relatively cheap. They certainly weren't when I was growing up. If you wanted to take an interest in astronomy and use a telescope, you had to build it first, unless you were very rich indeed.
Well, our podcast group people had a recent little sort of tete-a-tete with each other over telescopes. I'm sure they were all comparing, their equipment.
As you do.
I think a young lady won that competition.
Okay, that's good to hear, because that there's a lot of astronomy is a gender non-specific hobby.
Oh, yeah, of course.
And telescopes, as I said, you can get fantastic telescopes now for a really relatively low price. And in fact, $100 would buy you a telescope that I would have loved to have had when I was a lad at school. But in many ways, it's the sky's the limit. You can. I think even with the most, even with $100 telescope, you would still be able to see things like some of the rings of Saturn and some of the moons of Jupiter. As you progress through the price range, and really what you get is what you pay for, then you get to telescopes that are on mountings that will allow you to take deep sky photographs. If you've got the right kind of equipment, you can spend on astronomy. It really depends on just what your resources are like. And I actually have always been a great enthusiast for beginners to buy a pair of binoculars, because not only can you get lovely views of the moon, and on dark nights when there's no moon in the sky, and if you're away from city lights, you get beautiful views of things like star clusters in the Milky Way, that sort of thing. They show up really well in binoculars.
And people have actually published, even on our podcast group page, photos they've taken with a digital camera through their telescopes, and they've come up with some great stuff.
Yeah, they'd be brilliant. So what I was going to say about binoculars is you can also use them during the day. They're handy instruments as well as being an astronomical tool. But a telescope is what most people want, and by that usually they mean one that's mounted on a stand. And often the stand is actually what differentiates between a good one and a bad one, because there's nothing more frustrating than having a telescope on a flimsy stand that's vibrating all over the place. You're trying to look through it and find an object, and it is not the easiest thing in the world. So the quick answer is you get what you pay for, but there's plenty there. Lots of websites giving you comparative, assessments of different telescopes, usually run by commercial organizations, but most of these organizations, and I won't name any because I don't know where Jared's from, those organizations are not so much out to make a fast buck as to get people interested in the hobby. They're usually run by, the telescope shops are usually run by people who are also amateur astronomers, so they know a lot about it, and they're keen to engage people and let them see what a marvellous hobby astronomy is. Quickly moving on to the question about
the mass surrounding us.
Yeah, whether our universe, if there is such a thing as a multiverse, and we really don't know the answer to that, multiple universes, could the gravity gravitation of an outside universe be affecting our own? And that's not a daft question. There are people who think about things like that. One of them, whose name I've mentioned, I think, many times before, is, and I've forgotten it now, so it doesn't matter. It'll come to me in a minute. A very great mathematician who postulates the idea that one universe eventually generates another one via the mechanism of black holes. It's very embarrassing that his name was on the tip of my tongue a minute ago and now it's gone. But that's what happens when you get to be 150 years old.
Yes, yes. And always happens while recording a podcast.
That's right. But the point I wanted to make about this is gravity. So 4 fundamental forces of nature. Gravity is the weakest, and it's not just the weakest by, a little bit. It's let me try and remember it. It's something of the order of 10 to the 18 times weaker than the other fundamental forces, and so there is something about it that's very different. And some people suggest that that's because perhaps gravity leaks out of our universe into other universes. And if that's the case, then you might expect there to be an imprint from other universes on our universe. And the place to look for that is the cosmic microwave background radiation, the flash of the Big Bang, which itself is mottled with slightly warmer and cooler temperature changes, and so which are essentially caused by sound waves in the flash of the Big Bang. That might be where you might find evidence of the gravity of another universe impacting on ours. It's unlikely, however, to cause the acceleration of the expanding universe, because I think that is too great to be basically the reason for it.
Okay, very good. Jared, as an astronomy student, you get an A+ for asking those questions because they were thought-provoking. Well done. Let's move on to the next question, and it comes from Michael Brill. Now, Michael has sent us a stunning photograph that he took while at Mawson Station. Now, Mawson Station's in Antarctica. It's a research station. People spend, probably 6 months down there in rotation, going backwards and forwards. I know a couple of people who've done it over the years, and the only real way to get there is by ship. It's very isolated, and there was a famous case of a researcher there who got ill and had to treat herself by satellite phone to the doctors some years ago, which made the news. It's that isolated and quite an amazing place. So thanks for the photo, Michael. I do hope you put it on the Space Nuts podcast group on Facebook, because I think people would love to see it. But he said, hi, guys. Firstly, I'm a first-time, long-time. So first-time question, long-time listener, I assume that means. Spent all of last year at Mawson Station listening to your podcast. Wasn't there anything else to do? The trip was so good, in fact, I'm heading down again. My question is in regards to gravitational waves. My understanding is they stretch the fabric of time whilst not interacting with pretty much anything else. So, can they interact with each other? For example, if two waves converged or intersected each other, would the disturbance of time change? I hope that made sense. And that's an interesting question. In my new book, science fiction book that I'm writing at the moment, we do actually have multiple gravitational wave effects. So yes, the answer is yes.
Well, you can answer this one.
No,
then.
I have no idea. I just make that stuff up as I go along, as most science fiction writers do.
Yeah, indeed. Yes, some scientists do as well. Let me just backtrack for 5 minutes, because I remembered the name of the person whose name was on the tip of my tongue. It's Sir Roger Penrose, of course, is the person who's thought about the imprint of external universes.
Is he British?
Yes, British cosmologist.
I kind of figured with a name like that.
That's right. Okay, the answer to this question is I don't know. And I'm really interested to know what is the consequence of gravitational waves interacting with one another, because in the study of light, and maybe light is perhaps the bit of physics that I understand best, because that was what I did as my special topic for many, many years. When waves come together, they interfere with one another. And in fact, you can get the result where light waves actually cancel each other out if they are out of phase, so that peak of one corresponds with the trough of another, and suddenly they aren't there.
Like radio signals cancelling each other.
Yes, indeed, just like radio signals do. And I'm not enough of a gravitational wave specialist to know whether that is possible for gravitational waves to do that. I do, however, know people who are gravitational wave specialists, and I'm going to go and ask them.
There we are.
I'll catch up with one of my colleagues who knows about this sort of thing. I'll see him on Thursday at some meetings that I'll be at, and I would like to talk to him about exactly this topic, the interference of gravitational waves. I think it's a very, very interesting question. And so
maybe we can follow it up next week.
Yeah, so Michael, hold on, and we'll try and follow up on that. I think it's a really interesting question.
Very good. Thank you, Michael. Much appreciated. And thank you to everybody. I must say, Fred, in scrolling through the podcast group, I noticed a couple of people have put posts on directly pointing at you, your recent appearance on the drum.
Oh, good.
Yeah. There's also another photograph, if I scroll down far enough, of the Sherbet Life album cover, which we talked about last week.
Yeah, we did, yeah.
My favourite band growing up was Sherbet. I went and saw them once, and there's a photo of you with a space nut by the name of Carrie Brown, and I must send a special hello out to Carrie, because she's an Uber fan, and, especially an Uber fan of yours, I think, and yeah, lovely to see. So, look, that Facebook page is just going gangbusters, and it's great to see everybody interacting. It's not just about listening to us yabber on every week. It's all about talking to each other too, and learning from each other, and sharing each other's photographs and experiences in astronomy. And I think it's fantastic that everyone's doing that. And I think there's well over 500 people in that group now, Fred. So that's fantastic, isn't it?
Maybe they should include me, Andrew. If you want to send me Facebook 101, I might try and find out how to do it.
It's not that difficult, but once you're into it, it's very addictive, I think would be fair to say.
I don't want to do that. I've got enough addictions without Facebook.
Yes. But thank you, Fred, as always. It's a great pleasure, and a lot of fun.
Sounds good. And I hope we'll speak again soon.
I hope so too, because we've got to do a follow-up on one of your questions. So, yeah,
we do.
Get back together next week. We'll see you then.
Yeah, all right. Sounds great.
And before I go, a reminder that if you want to go to the Space Nuts shop, I can't believe we've got one. There are a whole heap of books available. Cosmic Chronicles by Fred Watson, Parallax by not Fred Watson, and a few other books there, and T-shirts. We're selling T-shirts by twos, but they're there as well. So pop along to Bytes, bitesz.com/spacenuts. You can listen to episodes there, as well as check out the array of product available. And our sponsor, of course, ExpressVPN. We thank them for getting on board as well. And thank you for listening. We'll catch you again next week for another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.